Okay, so we're moving on to section 9.2, reflections, also known as flips. So reflections are still examples of rigid motion because, again, the transformation, once you do it, the size and shape of the translated figure is going to be the same as the original. However, unlike translations, the orientation, the position on the page will change because you are actually flipping it over a line. It's going to be the mirror image of the original figure. So we're just going to be reflecting over 3 different types of lines: the X and Y axes, horizontal and vertical lines, and then the lines Y equals X and Y equals negative X. So the first examples are reflecting over an axis. So again, this is the X-axis, this is the Y-axis, and on all of these, my original image is white and the reflected image is shaded in. So I started with this original triangle, I plotted out my points, but this is actually pretty easy because it really just involves counting. So what I'm going to do on all of these is I'm going to count to the line of reflection from each point, and then I'm going to count away from the line of reflection the same number of units. So again, for my point A, to get to the y-axis, I had to go 1, 2, 3. So I'm counting away. 1, 2, 3. And there's my A prime. B is the same thing. 1, 2, 3, 4. 1, 2, 3, 4. And there's B prime. C was just 1 unit. So 1 unit this way. And there's my C prime. And again, once I plot out these points, you can kind of see a rule emerging that because I am reflecting over the y-axis, the y coordinates are not changing, the x's are. They're just the opposite sign from where they started. But again, I like to just count because why not? It's easier, at least in my opinion. I'm going to reflect over the x-axis over here, and it works the exact same way. So if I look at point A, oh, actually, I think I did that backwards. So here's my original, here's my reflected, but either way that you want to look at it, if I'm starting at A, I went 1 unit to the line of reflection, 1 unit away. If I'm starting at B, I went 1, 2, 3, 1, 2, 3. C, 1, 2, 3, 1, 2, 3. And D, 1, 1. Works the same way, pretty simple. Down here is just a slightly different example. I still did it the exact same way. So if I'm starting with D, 1 unit to the x-axis, 1 unit away. E is 1, 2 units to the line of reflection, 2 units away. F, 1, 2, 3 units to, 1, 2, 3 away. The reason why it looks different is because the line of reflection actually went through the original figure. That's why it kind of overlapped itself when I was done. But all of this was just done with counting. Now we're flipping over vertical and horizontal lines that are not the axes. So just a quick little refresher on equations of lines. The standard form was ax plus by equals c. Point slope form was y minus y1 equals m times the quantity x minus x1. And then slope intercept form y equals mx plus b. Right now, you don't really have to worry about using these. Hopefully they at least sound kind of familiar. But if you plotted these lines on a coordinate grid, they would all have a slant. So I like to remember that if an equation of a line has both an x and a y in it, it's going to slant somehow. But since we're doing horizontal and vertical lines, you just want to remember that x equals any number. X equals 5, x equals negative 17, x equals 20. It doesn't matter. X equals any number. You're going to have a vertical line at that number. Y equals any number, so y equals 1. Y equals negative 5, it doesn't matter. It's a horizontal line at that number. A lot of people mix these up because they think that x equals something is some line that's parallel to the x-axis. That seems to be the natural place that people's minds go. But you just have to remember, x only is vertical, y only is horizontal. So if I have to reflect over the line r equals -1, then, or x equals -1, for me, I'm going to draw that line in so that I can see it real clearly. So again, here's -1 on the x-axis, so I'm drawing in my vertical line at that point. I'm still counting, but where people are going to make a mistake here is they're still going to feel like they have to count to the axis. Remember, you're counting to and away from the line of reflection. So for point M, 2 units to the line of reflection, 2 units away. Obviously this y-axis is still there, but I kind of ignored it for now. Point N, 1 unit to the line of reflection, 1 unit away. Point O, 1, 2, 3 units to the line of reflection, 1, 2, 3 units away. Reflecting over a horizontal line works the same way. So if I'm reflecting over y equals 1, here's +1 on the y-axis, but I'm drawing a horizontal line at that point. Because really what that means is no matter what x is, y is still 1. And again, I'm just counting. So here's r, 1 unit to the line of reflection, 1 unit away. Q, 1, 2, 3, 1, 2, 3. T, 1, 2, 3, 4, 1, 2, 3, 4. And S, 1, 2, 1, 2. And there I have my reflection over the line y equals 1. Again, your first indication that you've done this incorrectly is that the two figures just don't look quite right. Okay, they should look like they're mirror images. These, again, throw people because for some reason they're just very honed in on the axes, but you have to look at the line of reflection. The ones that maybe just get a little bit more complicated are over the lines y equals x or y equals -x. So y equals x is a line that goes through the origin. The slope is 1 because I would rise 1, run 1, rise, run, rise, run. Okay. There's no b like in y equals mx plus b. There would be nothing in that spot. So really the y-intercept is the origin because the y-intercept is 0. The rule for reflecting is to just switch the x and y coordinates. So I'm going to actually write the coordinate points of the original figure and then just switch them. So the original point A was 3, -1. So A prime becomes -1, 3. Just switched them. B was 1, -2. So I'm just switching those. -2, 1. And C was 4, -4. And I just switched. -4, 4. So when it's reflected across y equals x, it's literally just switch those. The line y equals -x looks pretty similar, except it's slanting in the other direction because the slope is actually -1. So it still rose, but I ran in the negative direction. This rule is switch the x and y coordinates and the signs. So my original D was 0.01. So I'm switching them and I'm switching the signs. -1 and 0 stays the same. The original E was 3, 3. So I switched them and switched the signs. So E prime is -3, -3. The original F was 3, 1. So when I switched the numbers and switched the signs. So now I have -1, -3. The reason why it's just better to follow the rule here is because it's difficult to count accurately on the diagonal. I mean, you could still count it, but you'd probably want to use a ruler. You'd have to make sure everything is perpendicular. It's actually just easier to follow the rule. And you can still see that it does make sense when I flip those over the line. So that is basically translations in a nutshell. Now, if you had to figure out the translation or the reflection rule, you'd really have a figure where you were given both of these shapes already, and you'd have to figure out the line that it was reflected over. And the best way to do that really is to just take a point, a corresponding point, so your n and your n prime, and think, where would they meet in the middle? You know, if I looked at M, here's where they would meet in the middle. Again, you're just looking at a point, where would that middle spot be? And it should be the same for all of the different letters that are on there. You're just looking for that middle spot, the line that it would have reflected over, and that's how you're going to know how the reflection actually happened. A lot of these things really are just, you know, two sides of the same coin. So you're either going to do the reflection or have to identify what the line of reflection was. So that's it. And again, if you had any questions on this, you want something clarified, please don't hesitate to email any of us. You know, set us up for some kind of a chat or video conference. We're all practicing our technology and we really do want to help. So there you go. And I will see you on section 9.3.